Cohen-Sutherland line clipping algorithm. So when I say about a Cohen-Sutherland line clipping algorithm, we divide it into regions like this. So for every point, we will find an region code. See here, we are going to find the region code. What is this region code? This region code is a 4-bit code. Okay, so we have a binary value. See here, it is 1, 2, 3, 4. 4 bits are there, and each bit is going to represent something. First one is top, bottom, right, and left. So let's see how to do this. I think I want your answer for this one. See here, in the middle, it is inside, so I will put it as 0, 0, 0. Okay. Say here, what is this? This is top. What is this? This is bottom.
Bottom.
What is this? This is left.
Left.
This is left. And what is this? This is right.
Right.
What is this now? This is top, and also
Left.
it is left.
Left.
Okay. What is this? This is top, and this is
Top right.
right. Okay. What is this? This is bottom.
Bottom right.
Right. Okay. And what is this? This is bottom.
Bottom left. Bottom left.
Okay. This much only. So now what is top? Top is the first bit. So I can write it as top is 1. Bottom is, it doesn't have a value, 0. Okay. Bottom is, see here, top, bottom. Bottom is 0. What is right? Right is, again, it is not right. Left is 1. Are you understanding? So I'll write it as 1, 0, 1, 1. Okay. Clear with that? So I have to write it as 1, 0, 1, 1. So similarly, what is this part? Top is 1. Bottom is 0. Right is, it is right, 1. Left is 0. So with this, can somebody tell me what is the value of this one? This part? Top is
1.
1. Bottom is 0.
0.
Right is 0. Left is 0.
0.
So when I say about the bottom left, what is the answer? So what is this one? Top is
0, 1, 0, 1. 0.
0. Okay,
1,
0, 1.
0.
0.
1.
1.
1.
Yeah, 0, 1, 0, 1. Okay. So similarly, for this one, left, what is the value? 0. 0. 0. 0. 1. 1. Okay. So right is again
0.
0.
0.
0.
1.
1.
0. 1.
Okay.
0.
Okay. So again, bottom is 0. 1.
1.
0.
0. 0. 0.
Okay. Okay. So now, and now this one, bottom right.
0.
Yeah, 0.
1.
1.
1.
1.
0.
0. Are you understanding this now? So this is how we get the, so we'll put it as, okay. So this is how we put the region code. This is how we put the region code. So with respect to this one, so you should know this diagram. So with that, you can draw this one. So now see here, top is what? 100. It is a binary. When I convert it to decimal, what is the value? 8. So I can put top is equal to 8. So when I say about the bottom, the value is 4. Okay, 1004. Left is what? 1. Right is what? 2. So when I'm writing the program, I will write as, I will give it as a constant. For the right, I will be giving 0010. For the left, I'll be giving 001. Okay, with respect to this one. So this is how we write the region code in Cohen-Sutherland line clipping algorithm. Okay, I think you have understood this. Okay, line clip, the first step. This is the first step of your Cohen-Sutherland line clipping algorithm. So why are we doing it? So why are we doing it is, see here we have a window like this. See, here we have a line, 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 here we have a line. Okay, so now I can say, now with this, with thinking about that in mind, I can say that what is this? This is left. Okay, so when I say about this, uh, what is this? This is left. What is this? This is right. Okay, what is this? This is top.
Top.
Okay, so now what is this? This is
Bottom.
okay. So now we can understand how do I find that? How do I find? We find that, say for example, what would be this point? This point would be somewhere like this point, say for example, it will be 30 comma some 70. Okay, this point, this line, when I say it is 30 comma 70. So how do I find this point? I can say it would be somewhere around 60 comma 60 comma some 60. Okay, say for example. So what I can say is that this point, when I say 60 comma 60 is inside 50 comma, that is you find the range. 50 is 50 and 60. So when I say about this one, 30 we will check with the x-min. 30 is less than the x-min. What is the x-min? X-min is 50. So I can say that this point is on the left hand side. Okay, are you understanding? Okay, similarly, okay, so similarly, so who is Oppo A5? Yeah. Okay. So similarly, when I say about the, okay, see here, 30, I will check with the X-Men. Okay. So it is this. And similarly, the 70. 70 is greater than the Y-min. Correct. Y-min is what? 50. Understanding? So from this, I can say that my point 70 is here, 30 comma 70 is actually lying outside my clipping window. Okay, what is my condition? It should be greater than the x-min and y-min. Okay, so now my point is, this is, when I say about this one, this should be and. This is, both are not true. This is false, correct? When I say about this one, this is not, this is false. This is correct. Okay. So I can say that this point is outside. From this, I can say that it is outside the clipping window. Okay. Outside the clipping window. Oh, so I want to know what I should do. I should not consider this point. Okay. So I should not consider this point. So where should I find this point? I should find the point from here. So what is this point? This point, I can call it to be the, I should find the intersection point. Okay. So I should find the intersection point. So I should find the intersection point from here till here. And then I can draw the line. This is what is my line clipping algorithm. Okay. So we will see about all these things. Okay. So we will see the next slide. Okay. So to find the out code, see here, I told you something called the region code. Okay. This is called the region code. Okay. This is called the region code. Now I will call this to be an out code also. The region code can be called as an out code also to find out whether it is inside a clipping boundary region or outside. So how do I find it? So I have written a code for out code. Okay, compute the out code. How do I find it? So with the previous example in mind, okay, so it is say I have to find the above. So when I want to find it above, it is y max, correct? So we'll see this one. So when I say a point is here, above means it is greater than the y max. When it is below means what? It is less than the y min, correct? When my y is less than the y min, then it is here. Here, what is the condition? Can anybody tell me the condition for this point? Can anybody tell?
Greater than X max.
Yeah, greater than x max. And this point is less than the x min. Okay, that is what we can find out here. So when it is greater than y max, it is above the clipping window. So you are going to do, I will tell you what it is. Code is equal to, what is this similar? This is equal to code is equal to code bitwise r. Okay, so when I say it is bitwise r and top. What is the value of top? Top is 8. Why did I put 8? Actually, the top opcode is what? 100. Yeah, you remember when we have written the region code, the value of top is 100. Now I will find the code of my this one point. Okay, my line is there, 1 point I'll find. So here initially code is equal to 0. See here, initially code is equal to 0. So code is equal to 0. I am doing a bitwise OR and I am saying that it is top. Okay, so I will be getting a value like that. So it is above, if it is above the clipping window. So now the next point I can say is that if it is less than min, which one should I do? Can anybody tell me what will be the code? Code or equal to which one? Can anybody tell me if it is less than y min? Code or equal to bottom. Okay. Y is with respect to top and bottom. Okay. So the next thing, similarly, if it is x max, what will be the code? Can anybody tell? Code or equal to right. Very good.
Right.
So code or equal to right. Similarly, x is less than x min, I can tell that code or equal to left. So how do I find that? I can just look into this picture. As I told you, this point is what? This point is 30, 70, I told you. Okay. So I just will check like that only. Okay. So this is 30, 70. So how do I know it is on my left? How do I know it is on my left? I will just check my x is less than my x min. Okay, that is the condition. X is less than x min. Okay, so if it is less than x min, what I am going to do? I am going to do, can anybody tell me this code is equal to code or bitwise or what is it? X min means it is code is less than x min. What is my out code? Code or
Left.
Yeah, correct. Okay, that is what. So code or left. Okay, so at that time I can find it is on my left. Okay, so that is how we generate the code for everything. See here, when I say about this, this is our condition. Code is less than x min. So code or left. Are you understanding? That is what I was trying to explain. Clear? This is how we will find the outcode. Similarly, I can do for everything. Okay. So now my outcode is generated. So now the next step. So this is the next step. Okay. Okay. So you're finding whether my code is on the left or on the bottom or on the right or on the left. Knowing that, I should find the intersection point. Okay, so I told you, no, I should find out where it is, then I should find the intersection point. So what are we going to do with the intersection point? So now, so this is the final step. Till it is done is equal to true, I should actually do my program. Till done is equal to true, I have to keep on doing. Okay, so this is to tell that done is equal to true. So for that, what we are having is we are performing an AND operation. This we will see at the end. Okay, so now we will see intersection point. So how to find the intersection point? If it is top, okay, if it is top or bottom, we have to find the intersection point. Okay, so let's see the picture once again. So if it is top or bottom, okay. So if it is top, okay, consider this picture. for which one I should find the intersection point. Okay, I should find the intersection point here. So now listen carefully. I should find the intersection point. What is happening? The x value only I have to find. The x has moved. X is a question mark. The intersection point x is a question mark. Can anybody tell me what is the value of the y? The y will be, looking to the picture, can anybody tell me what will be the value of y? Y is, what is this line?
100.
Yeah, that is the y max, correct? Y is y max only. So I should find the intersection point of x, I should know. For this point, can anybody tell me what is the intersection point I should find? I should find the intersection point of, what is the value of x? X is 50. It is x min only. Okay, till x min I can have. What's the intersection point of y? Y, I don't know. Correct. So similarly, if I have a point here, again, see here, this is inside. Okay, for this point, for which one should I find? For this one is, can anybody tell me? For what is the value of x? X is, similarly, what is the value of x?
X is unknown, y is 50.
Yeah, y is equal to, can I write it as y min, correct? Very simple. Okay, similarly, the next point, okay, the next line I can say, what is this point? For which one should I find the intersection point? So I should find the intersection point for
Y.
X is which one? X is
X max.
Yeah, x max. Okay, x is x max and y is unknown. Okay, are you understanding? So now this is what we have to do. So we have to find, see, look at this one. Something is common. See, when it is on the left or right, we have to find the intersection point of y. Okay, can I justify it like that? I can put when it is on left or on the right. Okay, time is out now, another 10 minutes only. So when it is on the left or right, I have to find the intersection point of what? I have to find the intersection point of y. And when it is on the top or bottom, what I should do, I have to find the intersection point of, okay, intersection point of x. Okay, so this much you should know, and with respect to that, we will go to our, okay, so with this in mind, we will go to our next, how to find the intersection point. So how do I find the intersection point? Okay, so this is also finished. Okay, so now if it is on the top, okay, so I will keep this picture here. Okay, so for the top intersection point, what did I say? For the top, the intersection point is, okay, so for the top, the intersection point is, okay, so here, I think we can keep this and then do it. So for the top, the intersection point is x. See here, for the top, x is equal to x naught plus x minus x naught. What is this? It is x naught plus x1 minus x naught. Here we are using our 1 by m into, okay, the intersection. As you know, the mathematical formula we are doing, x is equal to x naught plus x1 minus x naught, y max minus y naught by the slope. Okay, we are doing the slope here. So that is the simple intersection formula, and y is equal to y max. See here, as you can see. Okay, so I think you are understanding this. See, x we don't know. This is the intersection point, and y is equal to y max. Okay, clear with that? Okay, so the next step for okay, that is done. If it is for the bottom, what will I write? Bottom is the x which you don't know. Okay, x we don't know, the intersection point I have written, and then what is the y is equal to y min. So we'll see what is y is equal to y min. Clear with that? So we found the things for your intersection point on your left and for the top and bottom. Similarly, the intersection point for your right and left. Okay, so we can see this one for your intersection for the left and right. So what I should do, I should find it like this. See here, on your right, for your right, what I should do, I should find intersection. See here, the y is my question mark. So y, and for the x, we know x max. Okay, so x is equal to x max. Similarly, for the left, what is for the left? We don't know y, we should find the intersection point, and x is equal to x min. Okay, so this is how we find the right and left. So when it is finally done, we should find out what is the value of your, so we found out the value of our x and y. Okay, so now for which one we have to put? We have to put the value of x naught is equal to x, y naught is equal to y. Okay, and that is, we are first finding 2 points. Okay, we have, for a line we have 2 points, correct? Say we have a line like this. Okay, we have a line like this. There are 2 points. What are the 2 points? We have to find for x naught, y naught, and then here it is x1, y1. Okay, so for the 2 points we have to calculate the same way. Are you understanding? So we have to find for the 2 points. So for 1 point I have found, and now for the second point I will be finding. Okay, x1. Similarly, we will find it. Okay, so now we found out for x naught and y naught and x1 and y1. The same step we'll be following. We will find out the out code and get it. Okay, now with okay, so we found out the points. So till which condition? Okay, so we saw the first one, no? Okay, so we saw another point. Till what we are going to do? Till it is till this condition. Okay, so till this condition, if outcode 0 or outcode 1. So outcode 0 is for which one? X naught comma y naught. Okay, and outcode 1 is for what? X1 comma y1. Okay, if this condition, we have to find the outcode. Outcode is what? The region code that I had explained. So with respect to that, when we find the outcode, okay, so logical OR is 0, trivially accept and exit. Okay, if this one is 0, accept and exit. Okay, accept is equal to true, done is equal to true. Okay, else if outcode and outcode 1, okay, logical and is not 0, okay, if it has a value, what does this mean? Here it means that this one has a value, some value. That is what? If it is not 0, you reject that point, okay, and you say that it is done. Okay, so you reject the point and say done is equal to true. So accept is equal to false. That point is false, and we say done is equal to true. We have to keep doing till this end. Okay, and finally we come with this point. Clear with that? So this is about your Cohen-Sutherland line clipping algorithm. Only 3 minutes more. I'll just quickly show you what are the things that we have seen in the Cohen-Sutherland line clipping algorithm. Just a recap. So when I say about the Cohen-Sutherland line clipping algorithm, first thing is to know about the region code. So you should know about the region code. Okay, so I explained clearly how you get the region code. So based upon this region code only, I'm getting these values. Okay, so I'm getting this 0, 0. Oh, okay, sorry. The right is 2, and the top is 8, and the bottom is 4, and so on. Okay, with respect to that, we will be doing this, and left is 1. So we'll, with respect to that, we'll be doing. And now we go to the next step, the clipping window. Every time we say a point, it is with respect to x min, y min, and x max, y max. Okay, we can have like this. So now we start with our algorithm to compute the outcode. How do? You do code or uh, the respective region, top, bottom, right, and left. So if it's top, it is Y max. If it's bottom, it is Y min. If it is left, it is X min. If it is right, it is X max. Okay, so we have done this. Then we have to check till which position we have to do. It's a while condition. Okay, so it's a do while condition. And then we have to find the intersection point, top and bottom. So for this one, we have to do the intersection points. So this is how we do the intersection points. So we have seen this, how it works. Left and right, we find the intersection points, done. And finally, we have to accept it. We have to find the two end points of the line. So this much is about your Cohen-Sutherland line clipping algorithm. Okay.